Okay, so today we're learning how to use a problem-solving plan. I have one right here on the wall behind me. It gives you 4 good steps, but we also have one here in the book. Step 1 in using a problem-solving plan. Okay, in your problem-solving plan, step 1 is read and understand the problem. That's a big part of it. Read and understand the problem. Don't try to solve the problem without first reading it. Okay? And also understand the different components of it and what exactly it is they're asking you to do. You don't know how many times I've graded papers and people have answered the absolute wrong question. It says solve for x and they give me y. They give me everything but x. So and make sure you understand what exactly the question is asking you. It doesn't hurt. I mean, it does when it's in the book. But if it's on your test or something like that, it doesn't hurt to underline key phrases and numbers and units and things like that. And just kind of highlight the little pieces of information that you're going to want to use. Second step, make a plan. Decide what approach you're going to use to solve the problem. Maybe you should draw a picture. A lot of times drawing a picture really, really helps. Maybe you need to come up with an equation. Maybe you need to combine some of those methods. Third step, solve the problem. In other words, carry out your plan. Once you've decided what you're going to do, the next step is to do it. And the fourth, and one of the most important steps in this process, look back. In some cases, you can actually check your answer. You can plug it back in and see if it works. In other cases, just look back and see if it makes sense. I can't tell you how many times I put a question on a test, or I've seen it on Regents exam or something like this, and it said, you invest $1,000 in the bank this year at 6% interest. How much money do you have after 3 years? And people put answers like $75 million. You can't turn $1,000 into $75 million in 3 years by putting it in the bank. It doesn't work. No bank is that generous. No bank's going to give you 6% to begin with. But even if they did, there's no way it's going to turn into $75 million. If it was 6% interest, in 12 years, it would turn into $2,000. No way it's going to turn into $75 million in 3 years. Not going to happen. So look back and make sure that your answer is reasonable. Okay? If you're coming up with a super big answer and you started with really small numbers, there's a good chance you did something wrong. If it's asking you to calculate the distance from here to the moon and you come up with 14,000 hours, you did something wrong because we don't measure distance in hours. Okay, I mean sometimes you do. How far is it from here to Syracuse? Oh, about an hour. Because an hour is the distance. How hot out is it today? I don't know, shorts and t-shirt. So look back and make sure that your answer makes sense and that it's answering the question that was asked. So let's look at example 1. It says, you run in a city. I saw a t-shirt once that I thought about buying because it's perfectly me. It says, I never run with scissors. Actually, those last 2 words were kind of pointless. I just never run. Nothing's chasing me. Why bother? Unless there's bacon. I'll run for bacon. You run in a city. For some reason. Short blocks are north-south and are 0.1 miles long. Long blocks are east-west and are 0.15 miles long. You will run 2 long blocks east, a number of short blocks south, 2 long blocks west and back to your start. You want to run 2 miles at a rate of 7 miles per hour. How many short blocks must you run? Now this example is telling us to read a problem. Okay, that part's done. And make a plan. So we're going to read a problem and make a plan. So we've read the problem. Let's see if we can pull out some important information. Short blocks are north-south, and they're 0.1 mile long. So I'm going to underline that. Short blocks, if I don't want you underlining in your book, but you could write these things down in your notes. Like write down, okay, key information. Short blocks are north-south, 0.1 miles long. Long blocks are east-west. Oh, look at that, I'm going to use a different color. That's why I put highlighters on the required materials. Long blocks are east-west, are 0.15 miles long. Okay, so short blocks. So if you think about it, basically what they're saying is the city blocks are rectangular, and the short side runs north and south, and it's only 0.1 miles. The long side runs east to west, and it's 0.15 miles. Okay, they're not square blocks; they're rectangular. So the east-west direction is a little bit longer than the north-south. Now, it says you will run, 2 long blocks east. Actually, I'm going to use the same color as I use for long blocks east and west. Then it says you run a number of short blocks south. That's important. A number. What does that tell me I'm going to use? I'm probably going to have to use to represent how far I run south. Yeah. A variable. Because I don't know exactly how many short blocks south I'm running. That's a missing number. That's probably what they're going to want me to find. Oh, look, it says how many short blocks must you run. So that's going to be my variable. But we'll get there. That's part of, constructing the equation. Then it says we run 2 long blocks west. I'm going back to purple because I have my long blocks are east-west. And back to start. Can anybody tell me what direction I'd have to run to get back to start? First I ran east, then I ran south, then I ran west. Which direction will I have to run to get back to where I started? South? North. Okay, I went east and then south. And then west, so I'm below where I was. I've got to go back north to get to where I am. So I'm going to use red for that one. Back to your start. That's going to be a northward direction. Now, it says I want to run 2 miles at a rate of 7 miles per hour. How many short blocks must you run? Now, let me ask you a question. In the end, it's asking how many short blocks must you run. Is there anything in there that discusses how long I spent running? Is there anything in that question that asks me how long I spent running? No. What does that tell me about the 7 miles per hour? Yeah. Sure. But it also tells me that if they're not asking how long I'm running, or if I want to complete this in a certain amount of time, or anything like that, that 7 miles per hour, the speed at which I run, is not pertinent information. I don't need that. Sometimes they'll throw in little bits of extra information just to mess with you. If they also asked how long it took me to run, then that would be important. Besides, I don't think that you can just say you run at 7 miles per hour. It really depends, like where you're running to or what's chasing you. Like if I'm running to the donut shop, I might go 10 miles an hour. And then running back home will be a lot slower after I've eaten my dozen donuts. So there's a lot of variables in there. But they're not asking about how much time we run, so that's just extra information we don't need. So, do we understand the problem? Okay, we're going to run this circuit ending where we began. They told us the distance for each block that we're running, how many blocks we're going to have to run except for the north-south, and how far we want to run total. So, we need to make a plan. I suggest we start with a picture, and then we use a verbal model to come up with the equation to solve. Picture can be really helpful. So example 2 asks us to solve this problem. So let's think about this. Here's our home. Big green blob. Just a big green blob. There's our home. Now we're going to run first. Which direction are we running first? Yeah, east. How many blocks do we run in east? 2. So let's go 2 blocks east. 1, 2 blocks east. Then which direction do we run? After we go east, where do we go from there? South. How many blocks? We don't know. Okay? It says a number of blocks south. So let's go south. Now, since we don't know how many blocks that is, what do you want to label it? We already said we need a variable. What variable do you want to use? Yes?
We can use M for miles.
M for miles. Okay. As in like Miles Davis? No? Okay. Then it says we run 2 blocks west. And then we go back to start. Now think about this. We already said which direction we have to go to get back to where we started. Which direction do we have to go to get back to where we started? What do we say? Up? You're going to run up? Okay, Superman. Yeah.
North.
North. We're going to run north. Now, here's the question. How many blocks north am I going to have to run? Who said M? Yana said M. Why is it M? Because
It goes south and blocks. So we need to go back home.
exactly. We want M blocks south. We're going to have to go the same number back north to get to where we started. Okay, if we had run 4 blocks south, we'd have to run 4 blocks north. If we ran 10 blocks south, we'd have to run 10 blocks north. Unless, the hospital was closer. Because I'm not running that far. So we're going to have to run M blocks back north. All right. Everybody get so far? So, here's our picture. Let's use this to make an equation. Whoops, too far. Try to get right off the screen. Much better. Okay, so verbal model. Let's think about this. I want to find my total distance, right? Total distance. Now, what is my total distance going to be made up of? Let's think about this. I'm running blocks, right? There's 2 types of blocks. What types are they? Long blocks and short blocks. So what I can do is I can separate my total distance into those 2 pieces. Total distance on long blocks and total distance on short. I'm going to break those up a little further too. Now, how would I find my total distance on my long blocks? Yeah.
You would add 0.14 times 0.15.
Okay, so you got the right idea, but I'm gonna change your operation there a little bit. So the length of one long block is 0.15. How many total long blocks am I going to do? 4. Okay, 2 east, 2 west. So what should I do with the 4 and the 0.15? Multiply them, okay? 0.15 times 4. So we've got the length of a long and the number of long. What is hashtag of long? That's a number sign, okay? Before that it was a pound sign or a sharp sign. So the total distance on shore should be the length of a short times the number of short. What's the length of a short block? What's the length of the short blocks, the north-south blocks? Cam? 0.1. How many total short blocks am I running? Not M. Yeah. 2M. Okay. Now this is a little bit different than the book. That's okay. Just follow along with me. Because we ran M south and then M back north for a total of 2M. Right? So if we simplify our equation here, what's 0.1 times 2M? Just multiply the 0.1 and the 2. What do we get? What's 0.1 times 2? Nope, you added the 1 and the 2. What's 0.1 times 2? Nope, that's 0.1 plus 2. Yeah, 0.2. 0.2m. Okay, and then we're adding that times 0.15 times 4. What's 0.15 times 4? Yeah. 0.60 or 0.6. And what's the total distance that I'm going to run? Wrong. I'm not going to run at all. But also, that's not the total distance we ran. Yeah.
We want to run 2 miles.
We want to run 2 miles. You can't just add the 0.6 and the 0.2 because that 0.2's got an m attached to it. So we can't combine them. All right. Now, we haven't yet gone through all of the algebra to solve this, so we're going to use a method called guess and check. It's real simple. First you guess, and then you check to see if you're right. Yeah. So, who wants to guess how many short blocks we would run? Just throw a guess out there. Yeah. 2. Okay, so if we put in 2, we got 0.2 times 2 plus 0.6 gives me 2. What's 0.2 times 2? 0.4. And is 0.4 plus 0.6 2? No. Okay, but that's okay. What does that tell us? Well, yes, it's not 2, but I think we can gather a little more information than that. It's not 2. What more can we pull out of that? Seth?
Maybe we could try 12.
Okay. Why 12? Why not 1?
Because 0.1 times 10 equals 1 mile.
Okay, we're not there yet. Why not? Why are you saying we should use 12 and not like 1? It's got to be bigger than using 2 because 0.4 and 0.6 only add up to 1 miles. So I haven't gone far enough, which means I need more of those short blocks, not less. Okay? So Seth wants to try 12. Let's try 12. So if I put a 12 there instead, what's 0.2 times 12? It's not 24. That's 2 times 12. What's 0.2 times 12? Nope, you're adding 1.2 and 0.2. Oh, I think Yana's right. But let's try what Seth said just so we can, see that he's wrong. 2.4. We got to work on our multiplication facts, guys. So now we got 2.4 and 0.6. Does that add up to 2? No, because 2.4 is already bigger than 2. 2.4 and 0.6 would be 3. Okay? So Yana suggested that we try 7. What is 7 times 0.2? Yeah. 1.4. Does 1.4 plus 0.6 equal 2? Yes. So that means M is 7. Now, let's make sure that we've answered the question. The question was, how many short blocks must you run? What should our answer be? Yeah? No. Yes. No. You're adding the 4 long blocks. We don't want to add the long blocks. We just want the short blocks. Let's look at our picture. On the top left. We did M on the left. M going south. That was 7 short blocks south. What else did we do? Bethany? That's right. We also did 7 short blocks north. Okay. So we need a total of how many short blocks? 14 short blocks. Is 14 a reasonable number of short blocks to run? I guess so if it's only adding up to 2 miles. 2 miles isn't too bad. If you came up with like 87 short blocks, that might be a little bit unreasonable, okay? If you came up with a negative number, also you've got a problem if you ran a negative number of blocks. Of course, I feel like anytime I'm running, it's negative. All right. Let's take a look at formulas. A formula is an equation that relates 2 or more quantities. You might want to write down some of the formulas that they give you here in the key concept box. Especially because you'll be using some of these formulas on your homework, and some of these formulas will probably appear on your test. So you're going to want to remember them. And when I say you're going to want to remember them, I mean that because you may not necessarily be given these formulas. You might have to remember them when you take the test and not expect that the test is going to give them to you. Okay, so once we have those formulas down, let's see how we would use them. Now we're going to pull in another formula that you should have known already from 7th and 8th grade. Let's look at example 3. You are making a leather book cover. That's impressive. We used to make ours out of old paper bags. But I guess if you have a dead cow lying around. Have you ever considered that if you're putting on leather, you're like crawling inside the skin of a dead cow? Yeah. It's kind of creepy. I know. It's like it makes the Empire Strikes Back that much weirder. Like oh, Luke was just putting on a big tauntaun leather jacket. Just was still full of all of the insides of the tauntaun. All right. You need a rectangular piece of leather as shown. So we have this diagram, this picture already given to us. Find the cost of the piece if the leather costs 25 cents per square inch. So here comes the important question. Let's make sure we understand what they're asking. So let's read and understand. Okay, we read. Let's understand. You need a rectangular piece of leather. Everybody have an idea what a rectangle is? Hopefully we understand the shape of a rectangle, okay? You stare at one probably 5 hours a day when you're watching TV or playing on your iPad or whatever. That's a rectangle. Find the cost of the piece if leather costs 25 cents per square inch. Let me write that down. 25 cents or $0.25 per starts with a P, not an R, per square inch or inches squared. What is square inch or inches squared a measurement of? What is square inches a measurement of? Yeah?
Length.
Not length, that would just be inches. Give it a stab, Emily. Area. It's a measure, when we square units, it's a measure of area. So if we're pricing this leather based on area, what do you think we need to know about that piece of leather?
How big it is.
Use a different word.
How large.
Use a different word. We need to know what its area is. If the price is based on area, we need to know the area of that piece of leather. Now, the formula that we use for area is determined by what shape we're on. Okay, we have a different formula for the area of a rectangle than we do for a circle or a pentagon or whatever figure we have. So here we have a rectangle. What's the formula for area of a rectangle? Everybody just like waits for Emily. What do we got, Emily? Length times width. Now they gave us the length and the width in the diagram. Honestly, it doesn't matter which is which, as long as you don't reuse one. Okay, 18 can be the length and 11 can be the width. It's up to you, or vice versa. Just don't use 18 twice or 11 twice. So we're doing 18 times 11. So if you plug that in real quick, what do we get for the area of this rectangular piece of leather? Yes? 198. And so if that's our area, and we're paying 25 cents per inch, we get our total cost by multiplying 25 cents by 198.